Okay, so the goal of this meeting, what I'm trying to do now is I want to show you guys just a brief introduction to the Thanos Project. The Thanos Project is our big project of the year. It involves a lot of different physics principles. Most of the things we've learned so far this year, it doesn't involve Coulomb's law, but other than that, it pretty much has everything we've learned so far in one problem, in one little project here. So today's video right now, this video you're watching right now, the goal is for me to introduce you to the project so that you can see what it is we're going to be doing. You can see it's not due until the 24th here. So we've got a while to work on it, but this is our big project of the year. You can see 100 points. So it's an important one. It's one we want to make sure we take seriously. So page one just kind of sets the scene. Here's the video clip here. I don't know how recording a video, watching a video on my weak laptop is going to work, and I don't want to violate any copyright or anything anyway. So there's a link to the scene, but basically the pictures here, you can see Thanos is throwing a moon down here at Iron Man, this is kind of like what Iron Man sees, his point of view almost. So Thanos, the way he does that, he doesn't use traditional force. He doesn't just use a lot of gravitational force. What he does, we're saying, is that he actually changes the fabric of space-time to change the gravitational constant. So capital G, which is usually 6.67 times 10 to the minus 11, that's what it always is in our universe. We're saying Thanos's magical gauntlet, his space stone, is able to change that. And by increasing G, the moon naturally is forced closer to this planet they're on and will slam into Iron Man. So that's the goal of this project long term, is what is G? How did Thanos increase gravitational constant of the universe? What is the new constant that allows all of this to happen? You can see here that's the goal. It's calculate G. So what is this project? Your role is you work for like the CECA podcast company. I know that's not a real company, but that's what we're going with. And you need to write a script for a YouTube video that can teach the audience, about the physics principles and equations that could be used to calculate how Thanos could throw a moon at Iron Man. So you need to write the script for a video. You don't actually have to make the video. If you do make the video, you'll get some extra credit. I'll go over that in a minute. But if you're shy, you don't want to be on camera, or if that's a lot of work, or you don't know how to make videos like that, that's fine. You just have to write the script. It can all be done on a Google Doc, and you don't actually have to make a video, and you can still get full credit. So there's an example video here. Again, I'm not going to show you a video in a recording video, but it's a little video about Captain America's shield and how that follows the laws of physics, and that's just a great example video. It's really short. It has great visuals and effects and things like that, and it's a great example video of how you can use a little YouTube to teach, kind of like I've been doing in this process. So you want to kind of script out a video you could make to teach other students. Again, that's our audience here, are other students who like the Avengers but maybe don't know physics yet, and you want to teach them a little bit of physics of what's going on here in this science fiction made-up situation with Thanos throwing a moon. So that's the goal, is to write a script for a YouTube video that can teach the physics of this, of how can gravity be changed theoretically, mathematically. Obviously, there's no real way to change gravity. Gravity is what it is. The universe does its thing. But we're saying Thanos changes gravity, and we want to do the math behind that and teach it to our fellow students using a YouTube video. And again, we just have to write the script. You don't have to make the video. So let's look at the points now, right? What do you turn in? You've got the script itself, and if you make the video, you get some extra credit, like I said. So the script itself, you want to say, what will you say So plan out what are you planning on saying in your video, and also write down, plan out what are you going to show your audience. So I hope my video is working, but we were just given these whiteboards, which is pretty cool. I'm hoping to utilize that in a video soon. And so if you have maybe whiteboards, something like that, you can actually draw up some videos or visuals and include them in your video. But even if you're not making a video, if you're just doing a script, you can still show me the pictures or sketches or whatever of what you would include in your video. Because no good video is just someone talking at a camera. You need to include something for us to actually look at. So that's what your script needs. It needs to have what are you going to say, what are you going to show. At least 3 visuals, please. So it can be pictures, graphs, diagrams, video clips, anything like that. There's a rubric. I'll go over that later, and actually I won't go over that in too much detail. I'll let you guys read that for yourself, but I'll show you that it exists. And also, one thing I want to note is I've done all the math. There's a file that has all the math you need done for you already. So you just have to explain that math. You have, in your video script or video, you have to show me that you understand the math, but you can just use my math. You don't actually have to do the math. We're going to take a quiz next week, probably, because I'm not going to give you like a whole 8 days just to work on this. Certainly the rest of this week will just be for this. And then next week we'll do a little bit of working on this project. And then that might become your homework while we move on to review and take our forces quiz. So on the forces quiz, obviously you will be doing the math. For this project, though, since I didn't even know if it was possible, to be perfectly honest, so I did the math the first time and realized it's actually not only possible, but not too complex. And so I will show you that math. It's really not too complex, setting up the free body diagrams and all that. And then in your script, when you do it yourself, you're going to have to show me that you understand what's going on, the physics and the math, but you don't actually have to do the math. The math is done for you. But if you go above and beyond and add your own math, especially with the triangle portion of this problem, you can go way past what I do. And if you choose to do that, obviously bonus points. Also bonus points if you actually make a video. So I'm not going to waste time talking too much about bonus points, but if you're interested in that, the instructions are there. What is it you're going to write about? That's very important, right? Okay, so okay, I'm going to write a script for a video. What do I include in that video? Right here is what you need to include. So you need to introduce the problem, right? We're going to need to make a lot of assumptions. This is not a real world problem. This is a science fiction problem. Nobody's actually thrown a moon before by changing gravity. That's very impossible. We're trying to do the math to see if it were possible, what kind of numbers are we looking at? So we need to assume the following things. We're going to assume that he's changing G. So that's what the space stone does when he makes the moon glow blue, excuse me. I raised the wrong hand with his left hand. That shows he's using the space stone. So blue is the space stone, and that means he's changing space-time. He's like making, warping around wormholes, things like that. And that's what he uses to actually change gravity and throw the moon. And so we're assuming he does that by changing G. So the space stone changes G, it increases G, which it would increase the force of gravity, and then the moon starts to, fall towards the planet. So that's the first assumption, is that, how does he even do this? We have to assume something. We're going to assume he does it by changing G, capital G, the thing that's usually 6.67 times 10 to the negative 11th. The thing that's always, I should say, not just usually, it's always that's a universal constant. Thanos is going to change the universe and turn that number up a notch. We're going to assume the planet Titan which is the planet this occurs on in the movie. We're going to say that's pretty much the same as Earth. Can't say it's, exactly the same as Earth, but we don't know much about the planet Titan. The characters on the planet, however, in the movie seem to be moving, about the same as they do on Earth, right? They're not hopping about. They're not getting squished by extra gravity. The gravity seems to be about the same. So we're just going to assume the planet they're on is about the same size as Earth. So same weight, same mass, I should say, and same radius as Earth. So that's the planet they're on. And we have even less information about the moon. We really don't know what's going on with the moon. So just to give us some numbers to work with, again, we're going to assume that moon, when we look up here, looking up in the sky, yeah, it looks like, about the same as Earth's moon. It actually looks a little bigger probably, but that's okay. It looks about the same size as our moon in the sky. So we're just going to say, here we are, sorry about that. We're just going to say, yes, it is about the same size as the moon, which is right here. So those are our biggest assumptions. We're also going to assume, it's about the same distance. So this is the average distance between the Earth and the moon. So we're going to use that as the average distance between the planet here that we're battling on and the moon that comes crashing down. So we're going to basically assume that this is the same thing as if Earth's moon came crashing down to Earth. Those are the numbers we're working with. So we've got Earth's numbers, we've got moon's numbers, we've got distance between Earth and moon, and we're just using those numbers to give us something to work with here. We also need time. That's going to be something we need in order to do our calculations. So you can use 10 seconds, or you can try to be more accurate. If you want to go to the video clip, remember I have a link to the video clip right here. So you can watch the video clip and actually try to get a more accurate time of how long does this take for the moon to come crashing down, and use an even better time. But if you just want to, give it a 10 seconds, that's approximate. In fact, when I was researching this project the first time, I found a similar video, someone kind of taking a different approach. They take a very different approach. So don't go think you can go find this video and it has all the answers for you. It doesn't. But they also did some calculations about this scene in the movie, and they used 10 seconds. So I just stole that. So you can use 10 seconds if you want to, or you can go stopwatch it, time it yourself, get even more accurate. You can see later when you get to the rubric, that would improve your score. So your video script, that's the assumptions, the 4 big assumptions is that we're changing G, we're using the Earth, we're using the moon, we're using 10 seconds or however many seconds you calculate or measure. You're not calculating that, you're measuring it. So your video should have 3 main parts. Part 1 is the introduction. You talk about what is the problem, what's going on. You guys can read, so I'm not going to go too far into that with this video, but basically explain what's going on. What's the goal of the problem? What's happening in the movie? Like, don't just start your video with like, the moon is falling and here's the numbers and blah, blah, blah. Like, set the scene a little bit. Explain to your viewers what's going on. So this scene in Infinity Wars and, whatever. Explain the assumptions as well. Make sure your viewers know where the numbers we are using are coming from. Explain what is accurate about our numbers and what might not be so good about our numbers. Where are our numbers coming from? This is similar to the child falling off a chairlift or Thor falling out of the aircraft. Both of those times we had to make some assumptions about where our numbers came from. This is no different than that. Make sure you talk about that. So that's the introduction. Introduce the problem, what's going on, introduce the numbers and where they came from. Part 2 of your video is the physics concepts. That's probably the most important part. That's where most of your points will come from, because that's the actual physics. So there's 3 main physics concepts going on here that you're going to need to address. There's the kinematic motion equations. So there's some big 3 equations work. You actually only need to use one of the equations in this problem, but you should still talk about that and discuss that concept in your video. How did we use the equation or equations to help us solve the problem? Newton's 3 laws. All 3 of Newton's 3 laws are represented in this situation, just like always. So talk about all 3 of them. Please discuss all 3 of Newton's laws in your script or video. And then finally, trigonometry, physics and 2D stuff, X and Y. There's an X portion there. So the first chunk of what I ask you to do does not involve X and Y. It's just one dimensional, one direction. Then there's part 2 that involves a triangle and some sine, cosine, SOHCAHTOA stuff. That's where you'll come in with this part here. So it's kind of a 2-parter problem. One that's just kind of a straight line, moon, planet, smash. There's another that actually adds a 3rd planet, the planet Saturn, in fact, because, well, we'll get there. We'll get there. I'm jumping ahead. But there's a second part to the problem with triangles. That's where you'll use the SOHCAHTOA stuff. Sine, cosine, triangles, all that. And then part 3 of your video, so that's part 2. Part 2 is the physics. You don't need to even talk math really much there. You just need to talk about the physics concepts involved. So how do we use these equations? You don't actually have to show the equations yet. You can save that for the math portion, or you can combine parts 2 and 3 and do the physics and math portions together. Like, you can do your video however you want, as long as it answers all of these things. So anyway, that was part 2, was the physics. Part 3 is make sure you explain the math as well. So as you go through the physics in your video, you need to explain the math, where those numbers come from. So anytime in your video that you get to a math step, here's what you have to do. You have to explain where the equation came from. Is it one of our kinematic motion equations? Is it an equation that comes from trigonometry, SOHCAHTOA, sines and cosines? Is it something like that? Is it an equation that comes from one of our force equations, such as gravity, G_mm over r squared? So where did the equations come from? Briefly explain the math you're performing. You don't have to teach it like they don't know what algebra is. You don't have to teach your audience how to solve for X. This isn't a math lecture. It's a physics podcast. So you can assume your audience knows math, is pretty good at math. So it can be a brief, quick explanation of math, but do explain the math. You have to, show your work, right? Even if you're not showing it on a whiteboard, even if you're just explaining it. And don't make a mistake. I know I made a math mistake on that one video earlier this week, and my bad, right? It was embarrassing. You probably sat there and you're like, that's an obvious math mistake. It's even worse when it's obvious. So double check your math. I even did the math for you. So if it's a math step that I've done for you, we've been using that same math for 2 years. So if you find a mistake, please tell me. That'll be very impressive, because that means that some 2 years worth of very, very good physics students didn't catch it. So if you find a mistake in my math, please tell me. But I think it's good. A lot of people have checked it. So check your math with my math. Make sure your numbers at least look reasonable. My math uses 10 seconds. Maybe you found a different number that's more accurate, so your numbers might not be exactly the same as mine in that case, but you can still use my math as a guide. That's pretty much it. Sorry, I just want to make sure I don't forget anything. There's a triangle portion that I'll go over later. I don't want to overwhelm you right now. It's probably already feeling kind of overwhelming. So one step at a time. If you like the project, you just want to attack it, all the instructions are done. As you can see, the instructions are all there. So you can go as fast as you want. But for today, I just want to give you the gist of what we're doing. So triangle portion, you can see the planet Saturn. So in the comics, the planet Titan that Thanos is from is actually Saturn's moon, Titan. That's not how they do it in the movies, obviously. Thanos comes from some planet way not in our solar system. But in the comics, at least in some versions of the comics, I don't know everything about the comics. I know there's a million different multiverses, but anyway, Thanos does come from Titan, Saturn's moon. And so for the triangle portion, we say that he's on Titan, Saturn's moon. Saturn is a huge planet, so Saturn's gravity actually matters too, and it forms a triangle here, and that's where we start to use some sine and cosine. So that is the triangle portion. You can see there's even a challenge, a little extension for, for those of us who like to challenge ourselves, and the rubric. And boy, is that a mess. So it's very easy to read if I can print it out, but since I can't print it and hand it to you, it's sideways. So I'll fix that in a moment. I'm already on it. Don't worry. And the math, we'll go over that in a bit. Not today. We're not getting into math yet today. Today I'm just explaining the problem. That's it. And then you're gonna, do like an exit ticket kind of thing. Discussion board, actually, not exit ticket, discussion board post. And that's all I expect today. All I expect today is for you to watch this video, kind of be like, okay, here's our project, here's what's going on. It's a lot. I'm gonna go put a chat post on it, discussion board post, and then I'm done. That's all you have to do. So, and then tomorrow we can get, a little bit more into the math of it or whatever. Which, please keep in mind, there's another thing I wanted to show you. So before we get into the rubric, because I've got you kind of held captive here. I know you want to see that rubric. Before we get into the rubric, so we've got office hours. If you go to calendar here and you click on calendar, I can't show you my calendar because I've just got some things in there that are confidential. But if you click on calendar, I've invited all physics students to Thanos Project office hours today, tomorrow, and Friday, where you can come and ask any questions you want. Science fair office hours were pretty successful yesterday. It didn't have too many people there, but the people who were there got help with their projects, and it was great. So we've got office hours every day this week. They're on your calendar. So go click on calendar. I'm not going to do it because I can't show you some stuff on there. And you can see that. So now let's take a look at the rubric for the Thanos Project. So again, I don't want to overwhelm you, so you guys can read. But basically, please use this rubric as a guide, and as well, of course, use the instructions as a guide. So just start at the beginning. What do you need to do? Boom, your script needs to include these 3 parts. So start at part 1. Okay, introduce the problem. Introduce the situation. Thanos and the Avengers are fighting. You don't even need to know the movie. You can just give them a very basic introduction of what's going on. Thanos is the bad guy. He's fighting against the Avengers. During the battle, Thanos throws a moon at the Avengers, Iron Man in particular. And we want to do the physics calculations to figure out, how that could happen and the numbers behind it. That's pretty much all you have to do. And then go from there. So just treat this like a checklist. Check off all of these things in your script, and you'll be good to go. So the rubric is available as well. So please, use this rubric. This is how I grade when I'm reading your script or watching your video. I'm looking, okay, does it do these things? Check. Right. Does it do these things? Check. Cool. Does it do these things? Not quite. Okay, so 80% it is, maybe 85% out of those 20 points. Okay, next column. Does it do these things? Check. Does it do these things? Well, maybe it only explained 2 motion equations, so it's better than 1, but it didn't quite get all 3. Okay, 75% then, between 70 and 80, so you get 75% of the 40 points. So this is how I grade. So use this rubric to help make sure you get the grade you want. And that's it. So then today's assignment, all of this, I didn't even get to today's assignment. Here's today's assignment, and you can see just 1 page. Whew. So after all of this, what you have to do today is watch this video, which you've already succeeded at mostly, and then go post in the discussion board. So this is everything this video already has, is kind of shortened down. So goal of today is get introduced to the Thanos Project. Great, we've kind of already done that with this video. We need to write a script for a YouTube podcast. That's our long-term goal by the end of next week. That's not what we're doing today. Today's goal is to get introduced to the project. 3-step process. Watch the Captain America's throws his shield video. I hope you've already watched that. If not, watch that. It's a good one, good example of a YouTube physics video, like the one we're going to be writing. Watch this video you're watching right now, so you're doing that. And the last thing you need to do to get your 5 points, which is actually 5 project points today, is go post in the discussion board. See the Coulomb's law discussion board. Over half of you right now are looking at this going like, oh yeah, I didn't do that. Because you didn't do that. Do it, guys. You know, we can't talk to each other. We weren't very good at talking to each other. That's not true. First period wasn't very good at talking to each other already. Fourth period was actually pretty good at talking to each other, sharing ideas, helping each other out, which is awesome. First period, a few people were very helpful, but it was a pretty quiet bunch. So use this discussion board as a way to kind of like, you know, even if you're shy, you can hide behind your keyboard and still type out a response to, you know, what's your reaction? You know, what are you excited or nervous about for the Thanos Project? So go post one new post about what are you excited about, what are you nervous about, and then reply to at least one other student, and that's how you get your 5 points today. And that's it. So thanks for watching.